This is Unit 3, Day 1, Part 2. It cut off. I had just found the z-scores from the McDonald's piece of meat that had fat of 9 and calories in 250. It was a coincidence that they both had a z-score of about negative 1.6. So I'm going to look first on my x-axis for fat. Negative 1.6 would be here. And my y-axis, negative 1.6 would be here. So this is actually the point 9,250, just standardized. So they're on the same units, and then that puts the very middle of our graph at 0, 0. So if you look very carefully, this exact shape is what we had up here. Okay, it's just been shifted, just like we do with any other z-score, like that. Okay, so then you have this 0, 0 in the middle. And it's useful for lots of things. Here's the first part, okay? It helps us decide if it's a positive or negative association, although we can clearly see that in this case. It says, since having the majority of points in quadrants 1 and 2, and a reminder from Algebra 1 is this is quadrant 1, 2, 3, oops, I can't do a normal numeral 4, okay. If it's in 1 and 3, it indicates a positive association. Okay, and we will use the products of the z-score of x and the z-score of y to help us calculate r. There are several ways to calculate r. And those of you that had me in IB last year, we used a different way. This is the one we will use for AP. In class, I will touch on the other ones, but this honestly is the easiest one as well. Okay, so let's do it. To get an overall sense of the relationship, we add up the products of zx, zy. So what we do is we find every z-score for every point. So we have these two, but then we'd find one for this point, and 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 we'd add up all the zx's and all the zy's. If the sum is positive, we have a positive association. If the sum is negative, we have a negative association. If there is no association, the sum should be close to 0. Notice here our sum is positive, so it matches our picture of it going up. Also, since the size of the sum will get bigger, the more data we have, we divide the sum by n minus 1 to find the correlation coefficients. So there were 9 data points, right? And we get an r of 0.997. Well, looking at that picture, that makes a heck of a lot of sense to me because look how closely these points fit a line going up. Very, very close. Note, and I've said this before, but I'm going to say it again, we use the word correlation in statistics when we are referring to the correlation coefficient. If you want to describe a relationship in a more casual way, you use the word association. If you're talking about a line, we're using correlation. Otherwise, don't use it. One way to remember is that correlation has an L in it for the word line, and association does not. Okay, another thing, R is also called Pearson's correlation coefficient from the statistician Pearson, who started using it. All right, just the last little bit. Okay, let's talk about the properties of the correlation coefficient, and you really do need to memorize these. And I'm not saying for class tomorrow, but I am saying by halfway through the unit, you better have this down. So again, read it before you go to bed. Go to bed, your brain will work on it for you. First property, the value of r does not depend on the unit of measure since r is based on the z-scores. Even if we find it a different way not using the z-scores, r has no unit of measure. Okay? For example, the relationship between height and weight is equally strong if we use inches, pounds, centimeters, or kilograms. Step number 2, again, what we just talked about, r has no units. Step number 3, the value of r does not depend on which variable is x and which is y. So if for some reason you put the responding variable first, you'd still get the same r, but it's not going to help you out as much. You need to always do explanatory variable here and the respondent here. But if you switched it, you would still get the same r, but the rest of the data would be funky, okay? The line of best fit and stuff would be funky. Then, okay, point number 4. R is again between -1 and 1. Okay, when r is greater than 0, the relationship was positive. When r is less than 0, it's negative. Okay, the closer r gets to positive or -1, the relationship is stronger and has less scatter. And the closer it gets to 0, the relationship is weaker and has more scatter. Part 5, r equals plus or minus 1 only when it is a perfect line. I talked to you about that about 5 minutes ago. Perfectly straight line. So everything you did in Algebra 1, okay, or Algebra 2, where you did y equals mx plus b, and drew the line through here, if you had found the r for that, it would always be +1 or -1, depending on the slope. Okay. This is the only case where the values of one variable can be completely determined on the value of another. The reason we have scatter here is maybe there's other variables, extraneous variables, or confounding, we should use the word extraneous, that are kind of convoluting our results. And lastly, number 6, the value of r is measured by the strength of a linear relationship. Again, r is only for linear stuff. Now you can find r for exponential and everything else, but it's got a different name and it's really something else. Okay? It measures how closely the data falls into a straight line. An r value near 0, however, does not imply there is no relationship, only there is no linear relationship. And you'll do a worksheet on that, not this coming class period, but the class period after that. For example, quadratic or sinusoidal data may have an r close to 0, even though there's a very strong relationship present. It's just a quadratic relationship or a sine relationship. Okay, here is the last part. It's a review from Algebra 2. Okay, there are 2 methods for fitting a line to a set of data and then finding the equation of the line. The one we use with the calculator, graphing display calculator, and you can do this one by hand. Ask my IB students, I make them do it by hand, is least square regression line. And this one is the best fit, the perfectly best fit because the calculator does it. But I want to show you how to do it by hand. So here is the by eye method. Okay, and what we have here is some hockey players where we've got their heights in kilograms and their weights in kilograms. Question, what's wrong with that? I hope you notice that height should be in centimeters. Kilograms do not measure length. Okay, and so what you do is you just you kind of draw a line that you think fits best through all your points. Okay, so everybody's by eye line is a little different. Okay, again, your guess is as good as mine. That's what this little lady is saying here. And I drew my line and said I think it goes through 160, 64. So that's this point right here. And it also goes through 190, 88. That's this point right here, or close to it. Okay. Well, actually, no, I lie. It doesn't actually have to be a point. So 190, 88 would be right here. It's a point on the line. It may not even be one of my data points. But I can use those 2 points just like I did in Algebra 2 if I find the slope and the equation of the line. Go in. Okay, so if we remember, we have x, y, and to find the slope is y minus y over x minus x. Your teacher may have taught you y2 minus y1 over x2 minus x1. Doesn't matter which order as long as these two are on top of each other this way. Okay, I am going to go ahead and do the 190 first though. So let's see, I'm going to do this one first. I have 88 minus 64, y minus y, over 190 minus 160, and that gives me a slope of 4 over 5. Okay, so for every 4 units up, it goes 5 units to the right. Now I'm going to use the form. You could use either y equals mx plus b, okay, point slope, or you could use y minus y1 equals m times x minus x1, okay, which is, let's see, we have points, oh, let's see, this is point slope and this is slope intercept, so point slope, slope, intercept, I don't care if you remember those names. I'm going to go ahead and use this one just because I think often teenagers are more comfortable with it. So that's the slope intercept. So let's think about it. We know, well, we have an x and a y. Pick one. I'm going to go ahead and pick this y and this x. So y equals m. Well, my m is 4/5. Okay, and then my x from here is 160 plus b. Okay, if you do the math, you will get that b equals negative 64. Okay, and I'm going to pause and go ahead and do the math for you. I'm going to go back and do the math just to make sure you remember. So the middle step would be 4/5 times 160, which is 128, plus b equals 64, minus 128 from both sides, and you get that negative 64 I was talking about, which means your line of best fit is y equals 4/5 x minus 64. Okay, this is the equation of this line. All right, we will finish the rest of this in class next time. Have a good night.